اولین همایش ملی تخصصی کمپرسورها، ایران کمپرسور.
Okay, welcome from my side, ladies and gentlemen. First of all, I have to say that I'm very proud to be part of the first ICC and would like to say thank you for the invitation. And I will give you a presentation of revamp and modernization of reciprocating compressors. Let me introduce myself. My name is Andreas Hahn. I'm working for the NEA Group. I'm since 28 years now with the company and head of department for revamp and modernization since 2001. Today I would like to show you some details, basics of the product revamp and modernization, and I will inform you about we handle that product revamp. We'll give you some major topics for that product, like reapplication, re-rating, talk about controls, show you technical improvements. At the end, we will summarize in a conclusion, and you are free to have questions or for a discussion later on. The reciprocating compressors you find in several applications, mostly for the oil and gas production, but also for chemical, petrochemical industries, as well as for fertilizers, industrial gases. We are dealing on alternative energy market for biogas, also on the polysilicon market to prepare solar cells. Last but not least, also in the food industry or air compress industry. To give you a short introduction into the thematic of revamp and modernization, we face the situation on the market that operating processes are changing, and because of that changing, there are requirements for adaptation of the compressor, or at least technical improvements of the compressor. Here that product, revamp and modernization, is used to adapt the existing well-known compressor that you are dealing with and the compressor equipment, even for changed process data or for new technologies without buying completely new equipment. Revamp offers here to use the typically tailor-made reciprocating compressor for even change requirements or to improve the reliability and availability according to your situation on site. When do we talk about revamp? What kind of project is a revamp? And I would like to give you a short definition for that. We say any modification on reciprocating compressors that require to change documentation. This means for us we're talking about a revamp. The other thing is repair or spare part, where we replace parts one by one. But for a revamp we have to change the documents, and so this is the signal that we are going for modification. I have to give a strong attention here at that point. It is necessary that the compressor is without any performance problems or technical defects. This must be clarified before in form of a root cause analysis to verify what is the problem with the machine. Otherwise, we cannot improve into the right direction. At the end, a compressor revamp can be changing single parts or components of the machine. It goes up to relocation, so it can be a complete new turnkey system in the end, when we are just using the driving mechanism, for example. There are certain reasons for revamp. There are mostly the process design data, what is changing. We have here new operating conditions, for example, having new gas analyses, would like to change the pressure levels to higher or lower levels. Capacity increase or even capacity reduction sometimes is the point. And also a complete new compressor application might possible with the revamping it. The other big reason to do a revamp, these are technical modifications. We heard a lot about that today, improving reliability and availability of the machines. We have a strong research and development group. Even the reciprocating compressor is developed in Technic further on. So nowadays there are new components according to the technical state of the art what we can offer. We can offer compressor upgrades, reinforcements, for example, and change the machine for safe and easy maintenance procedures or to increase the lifetime. Another reason, technical reason, often asked for is the optimized compressor control. Nowadays there are new systems on the market, I will come later to that point, that show higher efficiency, give more flexibility, and in the end also power saving. New accessories sometimes also are the reason to do a modification when there are no spare parts anymore available for existing oil systems. A new pulsation bottle or better cooler need to be installed. This is also something what is a reason for revamping. At the end, the revamp and modernization work can be carried out on all brands of reciprocating compressors in response to the technical and economical needs of the operators. And normally the advantage for the customer, he will receive a machine according his request, but with a considerable cost advantage compared to a complete new installation. We talked about documentation. There are a lot of compressor brands in the market, and Newman and Esser Group has a lot of licenses, machines, so we are able to calculate also different kinds of reciprocating compressors, not only the Newman and Esser ones. Coming to my next chapter, this is revamp handling, how we are doing that. And this we normally do in 2 steps. The first step that we consider is a recalculation of the as-built situation. We have to match with the measured operating conditions of the machine to find out that the compressor is okay. And based on that layout, we go ahead. In step 2, we do the same calculation again, but based on the new operating conditions. And we are checking the thermodynamic, the road loads, to evaluate if a compressor revamp in general is possible or not. A positive pre-check of a machine means that there is a possibility to start a revamp project. In the next step, a detailed verification of the machine becomes necessary. Therefore, we're asking for a feasibility study. With the feasibility study, all compressor details are checked, the layout is prepared for technical improvements and verification by the design group we can do. And is no documentation anymore available for existing machines, it's also possible to come outside and make a measurement on the belonging part to do a redesign and starting with a revamp. To find the best revamp measure, we are using an analysis matrix. We put different technical possibilities for the revamp on one side and compare it with project features like costs, like safety, efficiency, and by a special benchmarking and scoring of these different possibilities and features, we will find the best solution for the modification. We do that with an own software that we have developed to do the layout for the machines. We call it the KO3 software. With that software, first of all, the compressor setup needs to be done. We can arrange for horizontal, for vertical machines from 1 up to 6 cranes, double acting cylinders, single acting cylinders, whatever you want. For the existing Newman and Esser machines, there are all base data included in the software. For the calculation of other brands, we're looking for a similar NEA machine and model it in that way that we also can calculate a complete different reciprocating compressors according to that. So by that way, any kind of compressor, reciprocating compressor, can be represented. Thermodynamic calculation of the software is, for the product is necessary, and there we need the input from the customer, and I call it the magic 5 informations that we need there. The gas analysis, there must be clear suction pressure, suction temperature, the discharge pressure, and the required capacity. According to this 5 information, we are able to run the thermodynamic layout and configure a machine. What is essential for the machine? These are the compressor valves. We heard in the presentation this morning that the compressor valves are very sensitive and are the most incident for compressor failures. So together with the OEM, we calculate the valve dynamics and do the layout for the best compressor design. The valves are essential for the performance, as I said. When we have confirmed the valves with the OEM, in the next step, we are doing a check, a load check for the most sensitive construction groups of the compressor. There are, for example, the piston rod neck, there is a con rod, there is a crosshead that need to be verified. We are checking the loads for all the operating cases. For the normal operation, this is the blue bar that you find. We do it for the PSV set pressure, the red bar, and also for the idle run situation, because any recip need to be started. For the NEA machines, again, the 100% limits are implemented. For the non-NEA recips, we adjust the allowable loads according to the data of the OEM. In the end, no mechanical limit may be exceeded. Special examination is needed for the crosshead pin bearing, because there we don't have only one value that we have to compare. You see the red bars entering the 100% mark. But for the crosshead pin bearing, besides sufficient rod reversal, the maximum hydrodynamic oil pressure may not be exceeded, and the minimum oil film thickness must be there. The combination of everything shows if the bearing is possible to use or not. In case of exceeding that limit, we have another tool that we can use to verify that. Oh. Sorry. Okay. That's the elastohydrodynamic bearing calculation. By that tool, we are able to calculate the oil pressure, the oil film thickness, and can evaluate if the compressor can be further used or not for the modification. Last but not least, the crankshaft has to be checked due to several FEA simulation references that we did. The analytics inside our software approaches allows to verify the crankshaft strength most accurately. We can describe a bending line of the crankshaft, and with the weight of the flywheel, we also can check the main bearings regarding the pressure on the edge of the bearing, if it is useful or possible to install it or not. When we are upgrading a machine, when we are changing parameters, also for sure the power, the drive components need to be checked. This we do by torsional analysis, what we run separately from our KO3. And according to the new power, also the gas coolers especially need to be checked for increased capacities. Verification is mandatory, is done according to the data that we give to the OEM, and he does the detailed check on the vessels, on the coolers. Piping need to be confirmed. That sizing, the rating must be okay for the new conditions. And depending on the application, when we change vessels, when we change coolers, sometimes the routing need to be modified by doing a new general arrangement and isometrics coming from that. The pulsation dampers also need to be verified. Here we have a tool inside our KO3 to make a preliminary damper check, to compare the existing values with the required ones. What we find as a result of that calculation, we get a recommendation for dimensions and volumes, expected pulsation levels, and expected pressure losses. In the end, if it is not sufficient, we also deal together with third-party specialists for acoustical pulsation studies as well as mechanical pulsation studies. For revamp, we always have the advantage that there is already a unit existing where we can do measurements and match the existing arrangement to the model for the calculation to get a better result for the pulsation study in the end. In case pulsation levels are exceeded, we go stepwise forward. The first institution is considering orifices to be installed to reduce pulsations, installing additional supports, or if this doesn't help, we install new pulsation dampers, bigger volumes, or also acoustical filters can be used. Yeah, coming to the major topics, these are the frequent asked questions coming from the customer. For reapplication, there is a typical review changes due to gas properties that are changing, change in pressure and temperature levels. We have to adapt to new requirements, eliminate limitations and bottlenecking, or conversion from lubricated to dry running or vice versa. Re-rating, there we have the chance to enlarge the existing cylinder bores according to the limits of the compressor from the loading, increasing the stroke, varying the speed, or a combination of all of that. The best solution is found in the feasibility study that we run. Then we come, here's the next slide, to the compressor controls. Compressor controls, there is still the possibility to use a frequency drive for various speeds, but especially for high power consumptions, 500 kW upwards, kilowatt upwards, the solution is very expensive, and you always find you have areas for its resonances, for vibrations, what is not good. Yeah, thank you so much. Therefore, nowadays, mostly it is used the suction valve control, synchronous working, and here I would like to introduce you the flux-to-flow system. This flux-to-flow system is an energy-saving, infinitely variable control that allows to compress only the required amount of gas. It offers a very wide control range, between 110% approximately. Only electrical power for that is needed. It is an easy installation, even on existing machines, with low maintenance costs. The flux-to-flow, the actuator especially, is based on electromagnetic type. They are installed on the suction valve covers. We have a system control unit, an actuator control unit that is installed in a cabinet close to the compressor. And we have several sensors to monitor and control the system. This is how it looks like. These are the two magnets, electromagnets, inside the actuator, and how it works. This shows the picture here. We are starting on the one dead end center with the piston, the re-expansion phase. The actuator is in the upper position, so we have the standard re-expansion. Then we go for the gas intake. The actuator moves downwards, opens the suction valve so the gas can flow inside the cylinder. This is still all the normal behavior. We are at the other opposite dead end center. Normally the compression of the cylinder starts at that point, but the actuator is still in the upper position. In the lower position, keeps the suction valve open, and so we have a reverse flow up to that point where we come to that capacity that we want to compress for the cylinder. And the integral surface of the PV chart, that means the power consumption and means the capacity. And so you see on the next slide that the area what is not compressed is saved energy for the application. To show you the system structure in the field, we have the actuators on the cylinders, we have the cabinet close to the machine, and what is needed by customer is a 4 to 20 milliamp signal to control the flow. This is a picture of the actuator in the field. It is more or less comparable with a diaphragm cylinder, and with an adapter flange it can be connected directly to the existing suction valve cover. These are the application ranges. We can use this system up to 1,200 RPM. Suction pressure is about 120 bar. Control range we talked about already, 100 to 10%. Suitable for oil-free or lubricated services, suitable for corrosive environment, and allowable for hazardous areas for explosion-proof. This is the one possibility to control a machine, but we have another one. It is the clearance pocket. This is an old-fashioned idea, but with new technology. And to introduce it to you, I would like to show a short movie. Old idea, new technology. It is a clearance pocket control. You see here on the head end side of that double-acting cylinder a clearance pocket, but the special thing is that we have a poppet valve in between the clearance and the compression chamber. And the poppets of the valves, they are controlled by a special control pressure, and so the clearance pocket is not completely open during all time of the stroke, but only part-wise. And by part-wise opening the clearance pocket, it is possible to influence the PV chart again, to change the gradient of the curves, and influence the capacity. When we put the control pressure, like it is here, to the maximum, to the discharge pressure, then the clearance pocket is totally closed. We have 100% flow of the compressor. On the other hand, when we reduce the control pressure down to the suction pressure, the PV chart becomes a certain line, and so we have 0% capacity on the head and compression end of that cylinder. And according to that, we can regulate the flow of the compressor between 150%. The control pressure we take from the system itself. We have control valves installed in the suction line of that stage, in the discharge line of that stage, and according, again, to a 4 to 20 milliamp signal coming from the operator, this control pressure can be adjusted, and so we can vary the flow to the required capacity and have a very nice regulation without any additional components outside the compressor. Okay, now we go ahead. After that, compressor controls. The last topic, what we are doing with revamp modernization, this is technical improvement. And here we have the classical points where we look at the compressor, changing the materials of the bearings to have longer lifetime, improve the crosshead to piston rod connection for safe operation, varying the rings, the pressure packings according to the actual technical standards. Compressor valves need to be checked if there are certain problems with them, can be optimized according to the actual technical designs. Oil systems, cooling water systems or tempering systems, depending on what we are needing. Accessories can be supplied, instrumentation, monitoring, even that can be part of a revamp to improve the compressor performance. Yeah, coming to the end of my presentation, to the conclusions, and I would like that you keep in mind that the revamp in general is a good opportunity to make a compressor fit for new technical specification and process conditions, as long as the compressor is in a technical good shape. Sophisticated knowledge of the OEM you do the revamp together with is required. I showed you certain kinds of checks and verifications that are necessary to have afterwards a safe solution again. This is done by ordering a feasibility study. It is a lot of engineering work to come to that safe and good solution for the revamp. And in the end, typically a revamp means a cost and time advantage compared to new equipment. Documentation is mandatory for operating company to receive in the end the permission by the authorization to run that compressor again. So, I'm at the end of my presentation. I hope you enjoyed, and I just say thank you for listening. Okay.